Welcome back to my Vulcan 4x hunger run. In this episode we are going to be doing our smelting in our furnace setup and probably also trying to get a more less wasteful power setup going. So I've turned my gas mixer on and it should be pumping oxygen and hydrogen into this furnace, but it's not igniting, and for some reason the pressure doesn't really seem to be doing anything. It doesn't look like it's going anywhere. It's not like it's not pumping gas in. Maybe I'm not entirely sure what's wrong over here.
Hunger critical.
Alright, so it's debugging time, and we are going to go fish our PDA out of this vending machine, which already has the atmospherics motherboard or circuit board installed in it, which will allow us to examine the contents of the furnace and the pipes and such in order to troubleshoot what exactly is going wrong there. But now I see I have no power, so I can't turn my vending machine on. So let's just do an emergency battery swap here. I'll put a small battery in my suits along, since I can't get outside right now to put coal in the generator. It's still too hot outside. Okay, it's troubleshooting time. So the PDA with the gas board in it, or atmospheric circuit board in it, will tell you what the gas makeup is of whatever you're pointing at. So I'm going to point at the pipe by the furnace, and it has no oxygen. That's weird. Mixer should put some in this pipe. Oh, that pipe has nothing. I forgot to open the valve to let the oxygen flow through the pipe. Now if I turn my gas mixer on, it will probably work. It wasn't working before because the one side didn't have any oxygen, so there's no gas for it to theoretically mix. And now I can see the furnace is igniting and filling up with hot gases, which is wonderful. Except now we have another big problem. The super hot furnace is heating up all the gas inside this room, and the room's temperature has risen up to like 500 degrees Celsius. I need to quickly vent all of this out and try and get like a vacuum going in here, otherwise this furnace is gonna cook me and my fellow oxygen tank alive. This is a serious problem. This is not going fast enough. Let's also open the valve to the outside up to vent the furnace gases into the atmosphere. Hopefully I can get this room cooler faster that way. Okay, with the atmosphere approaching a near vacuum, no more thermal transfer is happening despite what little gas left being at 560 degrees. So I'm no longer burning crazy amounts of CO2 or risking my big oxygen tank exploding anymore. Alright, round 2. So we start by closing off the release valve and then start pumping fuel into the furnace and ignite it. And immediately we get good temperatures and pressure, so all is working well. 1000 Kelvin temperature there, very good. High pressures. We can start smelting the iron ore now, chucking it in the top. Now there's two phases to using a furnace. One is to melt the initial ores, which I'm actually waiting for the stack to melt each time before I put the next stack in, although it goes quite quickly. And you just need a sufficient temperature of some, I don't know, arbitrary amount to actually melt the physical ores. It's not the temperature listed on the wiki, which is used to smelt the desired output, like steel for example, but some other lower temperature. Then once the ores are all melted together, you need to match the temperatures and pressures listed on the official wiki to get the desired output, like steel in my case, and then hit the release valve while the temperature and pressure is in range of that. So you don't need to maintain that temperature and pressure the entire time from melting ores to releasing your desired compound like steel, but rather two separate phases, one where you have enough temperature to melt the ores, and two where you have the right ranges to hit the release and get the desired compound out of the furnace. In my case, I mixed 3 stacks of 50 iron and 1 stack of 50 coal together to make 200 grams of steel. After that, I immediately started releasing the pressure on the furnace because it's filled with a lot of junk gases that have cooled down majorly and would make further smelting difficult to do. So I'm releasing those gases out, waiting for that pressure to drop, and I can close the external vent and pump more fuel into the furnace and ignite it again for batch number 2. Now with our temperature and pressure back up, we can turn the gas supply off and start smelting our next ore. I think I will do iron. Iron requires 900 degrees Kelvin to smelt, and pretty much any pressure range will do. I'll just smelt 1 stack of iron off of the next, which is going to majorly cool down the furnace, but I'll do a second round of gases in order to get the desired temperature and pressure to be able to hit the release and get my smelted iron ingots out of it. Okay, now we're releasing the cooled junk gases into the vented atmosphere and just waiting for that to vent out a bit. Once the pressure is low enough, we can shut that off and start supplying fuel again to heat the furnace and get the pressure up. Okay, there we go. All nice and hot. Release the iron. Since our furnace is still nice and hot, we're going to add 25 gold and 25 silver. Start smelting that along. We're going to be combining those two things together to give us electrum, which is 1 part gold, 1 part silver. And that also we were able to release with the same pressure. We still had enough temperature in that furnace. Next up is gold, which is requires 600 Kelvin to release, so we're probably not going to make it there. We'll have to maybe just pump a little more gas in, see if we can get what we need. Yes, there we go. And we got our gold smelted. Next up, let's try the copper. Yeah, the temperature's still good. I'll leave the release valve open and out it goes once it's finished melting. Excellent. And now we're really pushing the furnace, so let's just release those gases. So I'm making this small little extension over here because I'm going to be moving my solid fuel generator over to this side. It was just the best placement for me given my current base layout, which is admittedly very bad. And we'll also be placing a little something else over here to help the situation out in a moment. The big battery, which I built at my electronics printer now that I have steel. This thing can hold a lot of power, and the solid fuel generator can actually put its full charge into charging the thing without wasting any power output, which is great, which means all that coal power basically translates directly into battery storage, which is pretty fantastic. I just had to move my electronics printer out of the way to make space for that new setup, so I'm going to put it over here on this side with the other two manufacturing machines. Just a little note on placing cables: don't ever place a cable over an existing cable line or delete a cable from an existing cable line while a manufacturing device connected to that power network is busy making something, because it tends to reset the data network and the power network, and the manufacturing machine will actually stop what it's making, and you'll have to start making whatever you were making all over again. You won't lose the resources for it, but you're definitely going to lose the time it spent making whatever it was making. Now I just need to manufacture some heavy cable. Unlike the regular cable, this cable costs both copper and gold to make. The heavy cable has a much higher wattage, what's the word for it, resistance? Capacity? Probably capacity. So while the regular cable I think can only handle something like 2 or 4 kilowatts, I can't remember, the regular cable can the heavy cable can handle something like 10 or 20. I also can't exactly remember. I think it's 20. But the point is, the solid fuel generator can put out 20 kilowatts of power, and it's going to pump that power directly into that battery as it's generating it. So only heavy cable can handle that kind of load. If you put regular cable down between the solid fuel generator and the battery, the cable is just going to burn out instantly. So you need to use heavy cable between those two. So in preparation for the SFG's relocation, we're going to lay down some chutes that are going to lead from an inlet to the input of the solid fuel generator, so that we can dump coal into it safely from inside the base without having to go outside and give it a bit of a coal whenever we want some power. So let's start off with a bend over here. There we go. Chute corner. And then over here we want to chute inlet. That inlet you can just literally drop stuff into, so as long as the entrance is facing up. Which is different from a chute bin that requires you to manually pull a handle to accept the item.
Hunger. Caution.
Then back to another corner, chute corner. There we go, and that can face outwards to where the solid fuel generator's import will be. Despite putting a big battery in place, I'm still going to have a power controller over here, since using that we can charge our batteries, especially our large batteries, and it also isolates the solid fuel generator, the battery, etc. from the rest of the network, which is something that will be important later on for a later venture that I won't spill the beans on here quite yet. Nope, that is way too hot. Retreat.
Hunger. Critical.
So So I'm going to vent myself some glass over here because I actually want to turn one of the walls into a window so that I can see with the charge indicator on the large battery so that I know when to feed coal into the solid fuel generator even if I'm inside the base. So I'm ready to do my switch over. I'm going to move that power controller across.
Jetpack on.
Its import is lined up with that chute nicely. Now we just need to connect its output power cable to the stationary battery.
Power low.
I'm actually short on heavy cable here, so I'm going to just move the stationary battery one block further back. That will save me a total of 2 or 3 cables with that new, no, yeah, 2 cables with that new position, and that should be enough to complete my line without having to go back and manufacture more heavy cable, which I don't want to do right now.
Low.
There we go, we can see the charge indicator nicely from here. I think we can test it out. Let's dump a bit of coal in this thing. Half a stack should do. I can hear it turning on, and there's the battery charging. Nice. Our batteries are charging nicely in the power controller. You can see by the green flashing light on the power controller that it's busy actively receiving power more than what it's putting out. Usually it's flashing red if it's putting out more than it's receiving. Alright, that's all for now. In the next episode we're going to smelt 1 or 2 missing metal compounds with our furnace, and then we're also going to be messing around with some automation. We'll be playing with an IC chip, so stay tuned for that. Until next time.